Question number 16, we're going to test this series for convergence, for the radius of convergence and the interval of convergence. Just make note here that we have this n series part. Okay. This n series part here and our power series part here, which I've kind of split up. So we're doing our ratio test. So I have the n plus 1 in the numerator, and I have the n in the denominator, and then I'm going to group my terms. So I'm going to group together here. I'm going to do this. We'll have the negative 1 to the power n plus 1. And we'll have the 2n in the numerator with it. The negative 1 to the n that goes with that 2n's in the denominator. And then the 2n plus 1 that goes with that n plus 1 is in the denominator. I'm also going to split up the 2n minus 1 and the 2n plus 1 and group those together. So the 2n minus 1 and the 2n plus 1 are grouped together like that. Okay, so when I divide out the power series, n plus 1 divided by n is going to just give me x minus 1 to the power 1. And I want that all to be less than 1 to work out the interval of convergence using this ratio test. So some things will cancel out, so I'm going to end up, the negatives ones are going to cancel out. The n's, the n's will cancel out for the negative 1, so I'm just going to have the negative 1 to the power 1 in the numerator. The 2n's are going to cancel out, so I just have a 2 in the denominator. That 2n minus 1 over 2n plus 1, as a limit, that's going to go to 1. Okay, so let's just make sure we have clean up our terms here. So limit as n approaches infinity. Okay, so I have the negative 1 to the power 1. So I'm going to have negative 1 divided by 2. The 2n minus 1 over 2n plus 1. Again, I'm just going to keep track of that, but we know that that's going to end up being equal to 2 divided by 2, which is going to be 1. So 2n minus 1 over 2n plus 1. And then we have the x plus 1 part of that. So x minus 1. And that's all going to be less than 1. In the simplified form then, when I apply the limit, I'm going to end up with negative. That negative really is something I need to keep track of, but I'll just keep track of it just so that we know it's there. But we have these absolute values here. So I'm going to have negative x minus 1. That 2 is in the denominator, divided by 2. The 2n minus 1 divided by 2n minus 1 as n goes to infinity, that's going to be equal to 1. So just so that you can see that where that came from. So that's going to be from there. And value less than 1. Okay, so we can see that our radius of convergence is going to be 2. That when I can see that I have a radius of 2, so I'm going to maybe make a note of that. So radius is equal to 2. And when I solve for this, I'm going to end up with x minus 1. And I'll do it in 2 steps. X minus 1 minus 1 over 2 is going to be, get rid of those absolute values, and we know it's going to be less than 1 and greater than negative 1, which then makes my radius 2. So I get negative 2 2, and then solving for x, I'm going to add 1 to both sides, so -1 all the way to 3. So I added 1 to both sides of those two inequalities. So we can see that our center is going to be at 1, and make note that this horizontal shift does represent the center. This also helps us get the radius, because when we move it over, we can see that it has a distance of 2 from the center, and then we can get our interval by getting rid of that -1 with the +1 on both sides of that. So there's my radius so far. And if I want to get the interval of convergence, what I want to do is I need to test the endpoints. So I need to test. So I'm going to test the x equals -1 to start. So I'm going to test this endpoint and see what happens. And I'm going to test it in the original series. So I'm going to go back to my series, n equals 1 to infinity of -1 to the n over 2n minus 1, 2 to the power n in the denominator, and then the x minus 1 becomes -1 minus 1, so I get -2 to the power n. Okay, so that, I'm going to highlight that part. This part here comes from the power series. Okay, now the to the power n's are going to cancel out, so I'm going to end up with -1 to the power n there. And you should see that the -1 to the power n times -1 to the power n, when I combine those, are going to just be, well, that's going to end up being positive over 2n minus 1. This simplifies to 1 over 2n minus 1. This is a harmonic series. It diverges. Okay, so I know that my endpoint there, that's going to be just bigger than -1. Now I'm going to test the other endpoint. So I'm going to test x equals 3 in that series. So n equals 1 to infinity, and that becomes -1 to the power n. That's going to become 2 to the power n. Again, I'm just going to highlight that part. That's my power series part here. And I end up with 2n minus 1, 2 to the power n. Those 2 to the power n's are going to cancel out. So I end up with an alternating harmonic series. So this is convergent. So this is alternating. That means it's convergent. Okay, that means that this endpoint here is going to be included. So it's going to be less than or equal to or 3. So my interval is going to look like this. From -1, it's open. And then at +3, that's going to be a closed interval on that end.